So hi again, everyone. So for those who just joined, I am Nicolas Lesconec, in charge of the technology adoption here at Sigfox. So thanks to all of you for joining us today for this online session about the ultra low-cost design. So we'll first have a presentation that will last roughly half an hour, going over the infancy of the project. Why are we going towards ultra low cost? Why is that meaningful in the Sigfox context? Which use case can be targeted using this approach? Get into the technicalities about it. What does it mean in regards to existing Sigfox solutions, impact on the network, and so on. And then we'll discuss about industrialization and next steps regarding pushing those solutions to the market. So during the session, please use the questions box, which is in the interface of your GoToMeeting application. So you can ask any question you have about the presentation, be it asking for a clarification, asking about something which hasn't been covered in the presentation, extra information you want, and so on. And we will try to address as much of them as possible at the end of the session. And those that we won't have the time to address or that need to be privately discussed, we will do it afterwards offline. So today's session is presented by Christophe Jeloyan. Christophe has been at Sigfox for several years now and is the engineering director, what we call our network technology director. So in charge of everything related to the network technology, including the base stations, for example. And this ultra low-cost design is part of it, as it's tightly close to how our network operates, how it discovers messages, how it processes them, and so on and so on. So I'm now going to leave the floor to Christophe, which I thanks a million times for his availability, because he's got a very tight agenda, and I'm very happy that he managed to make the time to prepare this presentation just for you and to share with our community the latest news about what's happening and how you are going to build new project, new product, and improve your current operation. So Christophe, the floor should be yours in a few seconds. Let me open your mic, and here we go.
Yeah, can you hear me? Hello?
Yes, we are hearing you good, Christophe.
Yeah, it's okay. Okay, thank you, Nicolas. Thank you for introducing. Hello, everyone. Good morning, good evening, good afternoon, wherever you are, and thanks for joining. So let me start first with some, I would say, fundamentals. Oh, sorry, about Sigfox. Just saying that with Sigfox, the Sigfox technology brings a very disruptive approach in wireless telecommunications, specifically because Sigfox is like a signaling-free protocol of communication. Almost no protocol in communicating with Sigfox. There is no device attachment, no synchronization with the network. We have bring a full cognitive approach, SDR based in the infrastructure, specifically in the base stations. And we aim and we have delivered a seamless and global network which can interoperate with the devices globally. So that's a real new paradigm and new approach in telecommunications. And why did we make that? Is because we aim for the IoT, because of the mass volumes, we aim to make the devices as simple as possible in order to get the lowest cost and consumption, which would be required for the IoT solutions. And coming back on the cognitive side, so SDR-based network, that means that this network is capable to evolve incrementally with a full retrocompatibility with existing objects, like with a pure software upgrades, in order to go further and further in terms of complexity absorption to continue decreasing complexity at device side and make the cost and the consumption lower again. And today we made another step in that direction with this initiative. First, let me start. Sorry. First, let me start with some marketing inputs in order to bring the context and the use cases after. Sorry. Okay, so this slide is just to illustrate with the different solution verticals we can address with IoT. Just wanted here to say that, like for example, we have more asset tracking verticals use cases, like postal service industries. Just wanted to illustrate that the assets that can be tracked in an IoT solution will have a long journey and will experience different conditions, different usages in their journey, meaning that depending on where they are in this journey, the requirement of what should be monitored, what kind of data should be collected is various. And also the value of the asset that you monitor is changing in the chain, because could be high value assets sometimes, can be a batch of lot of low value asset like a pallet, for example, or a container. But when going downstream in the process, you will start having more and more small assets that will have lower and lower value. And when you go lower in this value, you will often have lower requirements in terms of data and I would say richness of that information to provide to the solution, to the tracker, to the solution, to the customer. So based on that, that means that and the usage are pretty different depending on where we are on the flow. And plus, in addition to that, the geographical repartition of those assets can change depending where you are in the flow. Upstream, you will certainly have, in the vertical of the asset tracking, again, you will certainly have some predictive path of the assets, because the assets or the group of assets cannot go anywhere. They pass through some warehouse, some highways, some logistic sites. But the more you go downstream, the more the localization of this asset will be spread and will become the more and more unpredictable on where it will be, because it is going close. So that was for this example of the asset tracking application. That's the message. Now, having said that, remember what I just said about the localization of the assets. They are in the predictive places upstream. Downstream, they are starting to get more and more unpredictable, spread on the territory. So that means that we have to have a strategy in terms of densification of coverage. So we have in Sigfox a strategy regarding that, because we have tailored coverage solutions. On the first line, we are going from a very wide area coverage like the satellite initiative we have, and going down and down until micro base station, mini base station, and the micro base station introduced now 18 months ago, I guess. So those coverage solutions allows us to make a densification strategy, us and our operators, of course, in order to get the right coverage and budget link for more technical guys on the territory. So that implies that the devices can also count on adapted budget link in terms of coverage. And that's why also we have a power class definition in the Sigfox specifications. And this power class definition will allow us to decrease power of devices, which will bring them less power consumption, and also would be more low cost. But this is possible thanks to this densification strategy. So regarding different use cases, so we have use cases that will be more high value assets that will require more smart devices, I would say, with more data, more dynamic data, more smart processing on the device in order to get the data elaborated at the right level. But some other the use cases will be much more basic, like acknowledge reception, which is something very binary in terms of use case, or the advertising and the mail opening use case. So I don't go into the details of the use case. I just wanted to show that regarding tracking, some applications have more or less complex requirements. And based on that, let's say we can talk about in this presentation about smart low-cost devices, which will be multi-sensor with long life duration, high value asset, and highly elaborated data to be transported, and more basic low-cost devices, which will be more suitable for some use cases because they target very basic requirements in terms of data to be transported. So I will go fast on this one, but I think you see my point. The ultra low-cost design we provided end of last year is effectively targeting the right side, a basic ultra low-cost device, which will have, of course, some particularities, some capabilities will fit with this kind of need. So it cannot necessarily fit with smart device use cases. So now let's go into this design and let's talk about what it is. So we introduced it. It was so during the Singapore Connect event. So it's a very, very, very basic design. So as you can see here in the picture, there is very few components. It has been showcased during Sigfox Connect in a button with a housing. I don't put the housing here because it was not a product. It was just a demonstrator for the showcase during the event. But anyway, it was exactly the same design inside, and it is basically a button. So when you press the switch, it sends a message with an empty payload. So basically, that's the function. It has. So this design has been designed for RC1, so Europe, roughly the European zone. It is uplink only, so on a transmitter only. Its power class is power class 2. Okay, not 0, not the maximum one. It implements the same mechanism of security and authentication as you all know today for those who are making applications with Sigfox. So it's a secure communication. This design has actually predefined messages. So as the payload is not dynamic, we are not capturing a sensor and sending a value that can change. The message are predefined in the memory of the device, and the button press will only transmit this predefined message. And when I say there is 512 messages, it's because for security reasons, we have rollover counters in order to make the transmission, each transmissions unique for authentication. So we have a 512 depth of transmission in this application here. And as you saw on the previous slide, it is coin cell powered with a basic CR2032 coin cell. So all the design is available on the build.sigfox.com. So you just connect, you type a low-cost ref design in the search bar, and you will find the material. You will find electronic BOM, the layouts, the schematics, documentation, test reports, and everything you need to understand how it works in deep details. Just a quick remark for those who will go deep in the details. The reference design you will find online is the design on the left side with antenna connector, because antenna depends a lot on the housing and the application you are doing. Okay, so it's a bit it's not necessary to give a generic antenna, there is no sense. On the right side, we put an antenna for the showcase and the demonstration during the Connect event, but it's not included in the reference design. So now coming back on the electronics, we use one of the simple transmitters we can find on the market that reach a very low cost and a very basic implementation. It's the CMT2189C from Hope RF. Hope RF is the manufacturer, the provider. So this chipset is actually including the digital part, the radio part. For the part, it's very frugal. We have very few resources. It's a 8-bit microcontroller with only 128 byte of RAM and 2K byte of flash. Okay, and regarding the radio side, it's a very basic FSK transmitter with a power amplifier integrated, which can be controlled in terms of output power. And that's it, and a bunch of 4 to 6 GPIOs to connect any trigger or any binary inputs. So when I told you at the beginning that we made evolve our infrastructure, our SDR software in the base stations, is to be able to receive the signals of such very basic transmitters that are on the market. So, and this one is one of those which have a very interesting cost. And we have to understand that it's an application of existing components that are available on the market, but we had to make evolve our infrastructure to be capable to collect them massively. I'll come back to that in details later. Regarding the costs, because it's the main characteristic of this initiative, I will talk about what we control. I mean, the cost of the electronic bill of material and the chip. I will not talk about end products because it's very related to the housing, the autonomy, and any other constraints that it's not generic. But for regarding the cost, the component, the chipset that is embedded here, we know that we can have it at 23 cents of dollars for only 3,000 units. So I let you imagine that there is still room for improvement in high volume. And regarding the complete electronic bill of material, excluding the housing, the mechanics, but all the electronics BOM, including the PCB and the coin cell, we estimated around 50 cents of dollar. So that's a rough an order of magnitude on what you can count on reaching in terms of electronic BOM. Now, what are exactly the impacts on the Sigfox specification and the Sigfox network? So, as I explained just right now, we had to make evolve the network to be capable to deal with those kind of chips. So we have an evolution of the RF specifications of Sigfox. Of course, if the RF specification moves, the certification process and criteria will evolve regarding. And the base stations firmware also has to incrementally upgrade to be capable to deal with it. So what are the main changes, the 3 major changes in terms of specifications? First, we relaxed the bitrate accuracy requirements of the Sigfox interface. So it's a relaxation, meaning that it's, of course, fully retrocompatible with the current ecosystem. And basically, we relax a lot because those kind of transmitters have a clocking mechanism, which is very cheap and not necessarily crystal-based. It's a bit technical, but let me go in a bit in technique. Their clocking system is not necessarily crystal-based, so they are often basic RC or LC oscillators that are pretty inaccurate. So first, this change is applied, and this is applicable for all power classes of Sigfox. Second change, the message counter length. The message counter length, for those who knows, is this famous counter incremented during transmission in order to get the authentication for security. So the length today was fixed at 4096 increments. We make it configurable in order to make it, to allow device makers to make it shorter in order to be able to deal with chips that with very, very few memory, like this one, 2K bytes only. And if we reduce it, of course, it has to be done taking into account the use case of the device and the journey, the lifetime. If a tracker has to work for 1 month, sending a message per day, meaning that it will come in, it will talk roughly 30 times, no need to have 4,000 transmission increments, so it could be lowered. So that's the idea. Of course, we can keep it at 4,000 if we want, it's configurable. And the last one is that we made the transmission mask relaxed, but this time only for the power class 2 or 3, meaning that power class 0 and power class 1 will still be at the same mask requirement as currently. And this is to cope with the architecture of very basic FSK transmitters that will have a spectral response slightly different from the current requirements of Sigfox. So please note that in that case, it's not a matter of the chip is not capable to transmit at power class 0. It's that Sigfox is voluntarily limiting it to power class 2 and 3 to save and to be able to handle the network capacity in very high volumes of traffic. So that was for the first, the 3 major changes of the specification. So based on those changes, we will have to adapt the certification criteria accordingly. So I already thought about that. And the test procedures have to be very simple because those devices are very basic. And of course, the base station firmware has to, the SDR side of the firmware have evolved in order to be able to receive those nature of signals in very, very high volume, massively parallelly, in order to still have a network capable to deal with a very high density of device. And regarding the timeline now, so we launch and we provide online the reference design in November. So we will certainly make some updates, minor updates to add some tests and information and some updates. But anyway, you have 99% of the content online. We will release in February the official new RF specification and certification specification, so that you can know what will be the certification exam, I would say, that the end product shall comply with. Very few time after, the network will be available for upgrade in order to be capable to deal with it. And we'll in H2 we will globally deploy in all Sigfox accredited test house the new tools and process in order to get certified in all our ecosystem of test houses. So that's for the timeline. And now some guideline. Now that you understand the design and what it do, and what are its capabilities, I would like to give you some guidelines on usage and use cases. If you want to implement this kind of devices in a Sigfox application. First, it's about the calculation capabilities. So you understood that it's a very basic MCU. So memory and processing is limited. You will not be capable to make dynamic payload. So it's for use cases where predefined messages are suitable. So meaning that any use case that will capture a binary event. Okay, here it's a button, so it will send an empty information, but I know that if it sends, I know that the binary event has occurred. The binary event can be the button press, can be opening a seal, can be a full tank or an empty tank detector, can be the door is open, the window has been opened. Anything that can be binary detected can be suitable with those kind of architectures. So that's what I call the golden message, saying you transport, what do you transport? It's an event. Another application could be a recurrent unique message, meaning that it's empty, but it's sent periodically. And based on that, you can make a basic Atlas native tracker, meaning that your target is not to capture an event, it's just to try to track this device using the Atlas native capability of Sigfox. That's a second possible application. And now regarding the power class 2, that could be seen like a counterpart because it's lower in terms of power. First, let me clarify something about the coverage. The coverage is first of all a management of margins in the budget link. Okay, we cannot say that power class 2 it works, power class 0, sorry, it works. Power class 2 it do not work. It is not so easy or white and black. It's about managing margins. So our operators manage to deploy networks in territories with a certain level of margin in order to ensure outdoor coverage and light indoor and indoor coverage. For very deep indoor coverage, you will certainly need to provide densification to improve the margin. So that's the point. So now, meaning that power class 2, for a nominal coverage deployment, would be suitable for urban areas where the densification is pretty high. So that's still to be confirmed regarding the rollouts. But for deployed territories, that's the case. In outdoor, so urban in outdoor, meaning that you are normally covered, it should fit. For the rural or for the rural areas where the densification is lower, so the margin are less, or in urban but indoor, in this case, you will be a bit short of budget link margin. So here, you could have some opportunistic or collection of message, or maybe you have to test your sites before confirming that it is suitable for a power class 2 device with a survey, or if it's suitable, of course, with a survey or field testing. And then it could fit also with coverage with particular areas, I would say point of interest, meaning that use cases where you know that assets or devices or objects will be in certain locations that are known. And then for those locations, you ensure that you have the margin in the coverage with densification solutions. with those in this condition, it's suitable. Anyway, for any cases, there is a need to have an analysis of coverage, and it has to be taken. The use case in its completeness has to be taken into account. That's it. So let's go for questions. I'm sure you have. I will be happy to answer.
Thank you a lot, Christophe. Very informative. Perfect on timing. So that's great. So yeah, we have plenty of questions. That's good news. Maybe I will start with a reminder, because it will answer to a couple of questions we got. So as Christophe said a couple of times, you already have a lot of information and documentation available online on the Sigfox Build platform. So the address is build, B-U-I-L-D, so build.sigfox.com. So here you can download this reference design, and you can find as well the full Sigfox protocol, which has been published in 2019. I got a question about that. Someone asking where the Sigfox stack was available. So it's available. The whole device interface protocol is fully open and available for download on build.sigfox.com. So this was for my intro, and now for the question. So one of the question was asking that is there a software sample code part of the reference design bundle, Christophe?
Yes,
Or are they
exactly.
purely schematics?
Yeah, you good point, because when I detail what is in the package, I forgot to say that the software is inside, of course. The source code with its associated documentation is inside, of course, and you will see that it's very basic, because remember, we have 2 KB of memory, and roughly half is dedicated to storing the predefined messages, and the other half is for the application code. So it's a code that is a bit lower than 1 KB, so it's pretty small. But the source is inside here. And just a remark, when talking about that, for those who knows applying Sigfox today, we are today providing a Sigfox library for devices. In this case, we cannot say there is a library, because it's a 2 basic code. Again, it's less than 1 KB. So it's a very basic code. So it's not a library where you can architecture and put an application above it. It's not such complicated. It's much more basic.
Okay, thanks a lot, Christophe. So we have other questions about this reference design. One of them is to know if there will be a reference design including a power amplifier, so to address other zones than Europe, Middle East, and Africa.
So today there's no plan to release that, but we checked the capability of the chipset to do so. So it is capable to cover all the frequencies of all the radio configuration of Sigfox, and we provided in the sample code, but also documentation explaining how to configure both frequency and both bit rate. So meaning that we aim that it is simple enough and well documented enough to be adapted very quickly by somebody that has downloaded the package.
Okay. Tricky questions about downlink. Could this reference design be modified to handle downlink communication from the network to the device?
So the answer is no. Let me show you. Do you see my slide still?
Yes, we are back on the OpenRef schematics.
Yep, that's it. So actually, no. I mean, if you stick exactly to this bill of material, it will be impossible because the single chip at the 20-cent single chip is a transmitter only. So meaning that it's doing downlink with this chipset will require a dedicated receiver aside. So strictly with the same bill of material, the answer is no, and that's part of the choices, the radical, I would say, strong choices of simplifications that leads us to a solution here that is 20 cents, and I think even below in high volume.
Okay, thank you. Let me pick the next question. Yeah, we'll stay on the hardware for now. We have a question which is about battery lifetime. So based on your initial testings or calculation, roughly how long will a typical coin cell battery last? How many messages basically could it power the device for?
Okay, so we made tests about that, effectively, endurance test, I would say, with coin cells, new coin cells, so freshly unpacked from their packaging. We reached 2,000 transmissions after seeing alteration of the signal, so the battery starting to be too low to get a proper signal transmission. So basically that's it. And with this battery, so again it's a CR2032 coin cell. So 2000 with a CR2032, and then we didn't try it with other kinds of batteries, but of course, as you can imagine, it depends on the capacity and the technology of the cell.
Okay, so roughly 2,000 messages with a coin cell.
With this reference of coin cell, yeah.
Yeah, to give an order of magnitude. Okay, perfect.
That's it.
And now I think, no, we are not going to leave the hardware design yet. Last one, a question about the antenna. So as you said, the antenna is not part of the reference design we're providing, but we have someone asking if the PCB antenna is something suitable for this type of application, performance-wise.
Oh yeah, absolutely. I would say it would be a pity if we have such basically strongly optimized design to get the lowest cost as possible. If we put a mechanical or electronical antenna on it, because the cost of the overall product will be strongly impacted by a mechanical or external antenna. So I would say yes, and we are encouraged using printed antenna because in terms of cost, it's almost nothing. But okay, this one on the picture, this one is not. We didn't take time to optimize it because it was just for a demo. But you can perfectly. It's 50 ohm. It's 50 ohm matching antenna, and you can find a lot of example designs on the internet if you Google it and try to make it match with this design. Yes.
Okay, thanks a lot. So we will now leave the hardware world and move first over the radio communication itself. I have someone who asked us if we can comment on the statement made by an IoT professional, so I don't know who, stating that the narrowband spectrum emitted by single Sigfox end devices causes strong interference to nearby existing wideband systems. More such Sigfox devices will further enhance the interference. Do you have an opinion on that, Christophe?
So if I understand well, the statement is that Sigfox transmissions So I would say
causing
device transmissions.
interferences to existing wideband systems.
If we talk about licensed wideband systems like cellular telecommunication for smartphones or Wi-Fi, I would say, of course not. And and I would say, thank God it's not the case, because we are operating in an unlicensed ISM band, okay, that exists for now decades, far before Sigfox creation, okay. And those bands, ISM bands, are regulated in terms of usage, in terms of output power, in terms of quality of signal. And those regulations are made in order to coexist with other wideband systems. And we, of course, comply with those regulations and those regulations in those bands. And that's why they are here. They are here to ensure interoperability and coexistence with the neighbor systems, wide or narrow band, any ones. So I would say no. The statement
Yeah,
is
so basically you
wrong.
disagree with that take. Maybe
Yeah.
to add on top of that, to the person asking that, so as Christophe said, it's really important to keep in mind that so Sigfox has both been designed to coexist with existing wireless solutions. So basically making sure we are still able to have good communications in an environment where there are plenty of other wireless protocols in this ISM unlicensed band. And the second is, as Christophe said again, Sigfox is compliant with telecom regulation wherever we operate. So the ETSI regulation, as we are mostly talking about Europe and the whole RC1 zone in Sigfox words. And we strongly recommend and we help our customers make sure they comply with that. So which includes the communication rate in Europe, for example, the duty cycle. So Sigfox has always been very careful about that. And to give you a recent feedback I got from the ground, so we have a major industrial customer in France, which I cannot name, but you could easily find it, who was worried about that, basically, and so which ran extensive tests on the factory floor and in the whole facility to make sure that enabling Sigfox communication on part of the systems would not mess with their existing wireless communication, be it on the 868 ISM band or other frequency bands. And the tests were completely positive, proving that the Sigfox systems were not interfering or provoking troubles in the communication of their other existing systems. So I hope it helps. So we have a lot of questions. Yes, maybe one. So I don't know if you will have the answer to this one, Christophe. We had someone asking if a specific connectivity offer will be added to the Sigfox operator's offer to accommodate for these specific use cases, typically a single message contract instead of a recurrent subscription.
Yeah, effectively today, today this design works with the current connectivity offers, of course, but effectively we could clearly imagine that if one device requires one single transmission in its lifetime, like for a seal on a container, recurrent connectivity usage are not required. So effectively we had in the pipes, in the plans, I would say, adapting some offers with those use cases, and effectively we are very attentive, cautious, I would say, on the opportunities in those use cases, and we are ready to trigger the deployment of an adaptation of the offer when the use case arrives, when a significant use case will require it. We are able, because we already think about the question. We already have made the analysis and the design of the offer in order to be able to release it once the opportunity comes out. But we didn't make it yet. We didn't deploy it yet. Right.
Okay. Thank you, Christophe. I think I went over all the questions that were in my inbox, trying to factorize them when possible. If you have any question, we will maybe wait a minute or two if you have any remaining question. In the meantime, I wanted again to thank all of you and to remind you that you can join the conversation online. We have an active community on Slack. So if you're not there yet, you can join us using the link at builders.iotagency.sigfox.com, which was in the last emailing we sent. So builders.iotagency.sigfox.com, and you can join our online community if you have any question, feedback you want to share, discuss with other entrepreneurs or people building projects. And the questions are coming. Yeah, okay. So Christophe, a last question, hopefully, yes, or not, about the power, the output power of this design. So you mentioned it was a class 2U for RC1. What's exactly the output power of this current prototype?
Class 2U, yeah. I will talk about the output power of the class 2U. So it's what is the range defined by the Sigfox specification. Class 2U upper range of the class 2U is 9 dB below the upper range of the class 0. So the absolute maximum power that the Sigfox device can transmit. So I will say it again. The maximum capability, tolerated power of this design is 9 dB below the absolute maximum power a Sigfox design can send. Now, again, remember, the design is capable to go further. The chip itself, the power amplifier is capable to deliver more, but the limitation in terms of certification, Sigfox certification, will be limited to class 2, which has 9 dB less than the absolute maximum. So let me, I don't exactly answer the question. In the RC1, it's 16 dBm ERP, sorry. So it's very technical. Effective radiated power is the absolute maximum power in RC1. So 16 minus 9, meaning that it would be 7 dBm ERP.
Okay.
That's
Thank you. Maybe one last question. Okay. I will try my luck, Christophe, and I will try to answer myself the next questions. Let's see how it goes. And tell me if I'm saying something stupid. So we got a question asking, this reference design is Sigfox Verify certified? And does the customer who uses this exact design have to verify? So my understanding, based on the presentation, is that this current design is not fully Verify certified, but the certification requirements are going to be relaxed in a few months, making room basically for this type of devices. Am I right, Christophe?
Yeah, that's it. Basically, that's it. I can rephrase because we have to distinguish the verified criteria as they are today online on the web are not yet updated. We will update it in February with the new criteria. Okay, so effectively, as the baseline of spec is not still updated, this one is not compliant, and it will be compliant with verified with the version of February, of course. Now, will we apply a modular approach, meaning that if you use it strictly identical, it will you don't need to do the RF and protocol tests. Yes, but you have to reuse it very exactly as it is, meaning hardware and software, particularly software. So if the software is the same, the binary is the same, and the schematics and routing is the same, you can inherit from the verified of it. Because keep in mind here that the software that is inside, the firmware, I would say, low-level firmware, is driving the radio at very low level. So if you change a timer, a register, a way to access to the memory, anything, as you are very, very low level in terms of code, it can have big consequences on the way the signal is generated, and then you can be you can go out of the Sigfox specifications if you do so. So the low-level firmware is very sensitive to the compliance of the specs.
Okay, thank you. And last question, I think this one is easy, even for me. Someone asking if there is a way to add a low power sensor to this design. And I think the answer is yes, as you mentioned, GPIO ports that should allow to integrate any external sensor, right?
Yeah, that's it. Anything that you can map on a GPIO and that can trigger the transmission can be added to the reference design. For example, a temperature sensor, you can add a temperature sensor on this design. You will not be able to transport the temperature information as it is dynamic, but you can do like a temperature threshold detector that will detect a threshold overpass, and when it passes over 4 degrees C, for example, the GPIO will trigger the transmission. So if you do so, you didn't make a temp sensor, a connected temp sensor. You made a temperature threshold overpass detector, for example, for cold chain monitoring. So anything that can be mapped on the IO and that can trigger the transmission can be added to this reference design.
Okay, great. So I think I went over all the questions of the audience. Thanks a lot, Christophe.
Welcome.
And
thank you for listening.
Yeah, go ahead.
No, I would just saying thanks to everyone for listening and for the questions. Very interesting.
Yeah. So yeah, thanks all for joining us today. As I said in introduction, we will share the slides with you, and the full recording of the session will be uploaded on YouTube either this Friday or next Monday. So anyone will be able to replay it as you wish. And we will have a second session later in January, which will be focused on data handling. So with Mark Puss, the CEO and founder of thosings.io, who will showcase how you could quickly build a demonstrator or handle your first fleet of devices very quickly by using thosings.io platform. And hopefully we'll be able to make a demonstration about how to integrate such a basic low-cost device on the platform. So again, and for the last time, thanks a lot, Christophe, for sharing all those information with us. Thanks all of you in the audience for joining us today. And please keep in touch. As I said, you can join our Slack online community, or anyway, register on to build.sigfox.com. We've got dedicated program to help you out if you are an entrepreneur, a small company, a university. We want to do our best to empower you to build your IoT projects and to succeed. So thanks a lot. Enjoy your day if it's morning time for you. Enjoy your evening if it's on your time zone. And see you for the next station in 2 weeks. Bye-bye.
Good. Bye-bye, everybody.